Single-plate clutch. Components and operation. Most manual transmissions and some automated manual transmissions are equipped with single-plate clutches. The main part of the clutch is positioned between the engine and the transmission. For seamless gear changes and a smooth pull away, the clutch temporarily separates the engine and the transmission, and then smoothly reconnects them. The clutch is controlled by the driver by means of a mechanical or hydraulic actuation system. Automated manual transmissions do not have a clutch pedal. Instead, the clutch is controlled by the electronic control unit by means of a hydraulic or electric drive. Let's take a look at the design and functionality of a single-plate clutch with a hydraulic actuation system using a manual transmission as an example. The following significant components make up the clutch: the clutch plate, or the driven plate. The clutch cover plate, that includes a pressure plate. The clutch also employs the flywheel, which serves as a drive plate. Finally, the clutch actuation system. In this case, it is a hydraulic actuator. The clutch cover is mounted on the flywheel. It clamps the clutch plate, which transmits torque to the transmission's input shaft. When the clutch pedal is pressed, the clutch plate disengages and stops transferring torque to the transmission, allowing the driver to shift to the desired gear. When the pedal is released, the clutch smoothly resumes torque transmission. Let's examine the clutch in more detail, starting with the clutch plate. The facings of the plate are one of its primary components. They receive torque from the engine while being clamped between the flywheel and the pressure plate. Slipping and friction help to ensure smooth torque transfer. Facings are mounted on cushion springs, which can compress, allowing for a smoother start or torque transfer. For better visual clarity, spring stroke length has been increased in this video. The input shaft of the transmission is inserted in the splined clutch hub, which receives torque from the clutch plate. The main plate and clutch hub are joined by damper springs, which dampen vibration. Moving over to the clutch cover. It is secured to the flywheel by bolts. The pressure plate is mounted on the clutch cover with the help of drive straps. The pressure plate clamps the clutch plate between itself and the flywheel, while the diaphragm spring generates the force necessary to press the pressure plate to the clutch plate using its elasticity. Two wire rings installed on the clutch cover support the diaphragm spring. When the inner section of the spring is pushed in, its outside part moves outward to release the clutch plate and thus stop torque transmission. The component that pushes the diaphragm spring is referred to as the release bearing. It happens when the driver presses the clutch pedal, thus activating the clutch actuation system. The two most common types of the clutch actuation systems in manual transmissions are the hydraulic actuation and the mechanical actuation. Mechanical actuation features a wire cable. This is a straightforward system but it is in many ways inferior to hydraulic actuation. Let's take a closer look at the hydraulic clutch actuation system. The system consists of the clutch pedal, clutch master cylinder, pipeline, clutch slave cylinder, fluid reservoir, and the parts located inside the manual transmission: the release fork, fulcrum fork, release bearing, and the release bearing guide. Note that the fluid reservoir may be shared with the brake system or may be independent. Besides, a clutch position sensor can be installed next to the pedal to inform the engine control unit whether the clutch pedal is pressed. Let's have a look at what happens when the driver presses the clutch pedal. When the pedal is pushed in, the piston displaces fluid from the master cylinder. The fluid is subsequently transported along the pipeline to the slave cylinder. Due to fluid pressure, the piston inside the slave cylinder forces the release fork via the push rod. The release fork then moves the release bearing, which presses the clutch cover's diaphragm spring, causing the pressure plate to slide backwards. After that, the pressure plate releases the clutch plate, separating the engine from the transmission. The release bearing allows the pressing surface and the clutch cover to rotate together, while the release bearing holder remains stationary. The design of the release bearing allows it to press the diaphragm spring from both the inside and outside of the bearing. Another bearing, the pilot bearing, is placed in the center of the crankshaft. This bearing provides support to the transmission's input shaft. This concludes our review of the single-plate clutch.